Okay, so this one's actually a little happier talk. This is a story that is, depending on how you look at it, either 56 years in the making or 15 years in the making. But we're actually announcing something that's coming up that we're producing here at BRI. It's a tool for landowners and agency personnel, stakeholders, whoever's interested, to understand pronghorn habitat change. And so this story, locally anyway, in the Trans-Pecos, starts in 2011. And as Sean was talking about, we've had an extended restoration efforts to combat long-term population decline in pronghorn. The Trans-Pecos population has declined from a historical peak in 1987 to a record low in 2012, just after those restoration efforts were initiated. And the causes are attributed to the typical four horsemen of population decline: as drought, barriers, predators, parasites, and disease. But we really don't have any hard evidence of what the root of that decline actually was. But the restoration efforts have actually been pretty successful. Like I said, those were initiated in 2011 with the first translocation of surplus animals from the Panhandle to the Marfa Plateau. And since then, there have been 6 translocations, most of which are in the Trans-Pecos, 1 in the Marathon Basin, 4 in the Marfa Plateau, and then 1 in the Edwards Plateau, but that's the wrong region, so we're not going to talk about that today. And as y'all saw in Sean's presentation, that's stabilized the Trans-Pecos population. It's not recovered to those historic highs that we were at, but we have stabilized it. And so without understanding necessarily what all those drivers were, we've been asking this question amongst ourselves of has the habitat changed? And the answer to that really is, of course, it has. Pronghorn are defined by adapting to change. They're extremely selective. Their physiology limits them to eating just the very most nutritious forage that they can find, which are the little weedy flowers that pop up after rainstorms. And so they're adapted to move long distances to find those. And so to do that, they actually engage in a behavior called surfing the green wave. And I don't know if y'all realize this, but pronghorn are pretty adept surfers. This actually is a theory that was developed in caribou up in the tundra, where like the southern end of their range warms earlier after winter. And so the vegetation actually greens up in a wave that moves from south to north. And the caribou actually follow that. West Texas, it's not driven by temperature, it's driven by scattered rainfall. So it's really more of like a paint splatter, but it's the same idea. And so we actually really need to understand how those patterns have changed to understand how pronghorn habitat has changed and maybe led to that decline. That's where the restoration really pays off, because we've developed a huge data set to understand how pronghorn are reacting to changing habitat conditions. And that started from the very beginning. In Marathon and Marfa, all of those translocated animals, a large portion of them were fit with GPS collars. This is from the first release. Those are the old days of store on boards, if some of y'all remember those. So that led to a data set that represented 391 translocated animals, but then we started adding resident pronghorn in 2020, and you can see when and how long those have been collared. But ultimately, right now, we're sitting at 2.83 million GPS locations, representing 537 individual pronghorn over a period of time that spans up to now 16 years. And so now we can actually ask that question: how has pronghorn habitat changed? The complement to this is a satellite. There's a lot of satellites we could choose from, but this one's pretty important. We can actually track the green wave from space. So no mirrors this time. These are the good satellites. Landsat 1 launched in 1970. That's the 56-year history there. And we're currently on Landsat 9, which has got a very long operational life ahead of it, followed up by Landsat Next, which is funded through 2045 at least. So we have a really long record to work with. And while it is a civilian program, it's awfully convenient for monitoring communist wheat yields. So actually tracking vegetation productivity is very well developed with this system. So we've been doing that since the early 70s too. So we know how to track where the vegetation's greening up. We're really good at that. But the problem was for a long time that this data set was so cumbersome, and there's a long, really interesting history of where those data ended up because they had to have ground stations in adversary nations to get the data. It's crazy. It was really difficult to access these data and use them. But that all changed beginning in 2017, but it really came to fruition in 2021. with the release of Landsat analysis-ready data. That eliminated many of the data access and pre-processing hurdles that made this a specialist-only product. Now it's accessible to those with a moderate degree of training in remote sensing, like wildlife biologists. And so it covers the continental United States. Depending on when you get the data from, it's either at 8 or 16-day intervals. But the record for this data set runs from 1985 to the present, which is awfully convenient since that corresponds to the historic peak of pronghorn in this region. The other part of this trifecta, and don't worry, this is not a stats lecture, is that the analysis methods caught up at about the same time. There's a particular class of models that allow us to isolate habitat selection behavior from movement data and actually accommodate changing habitats. These were the first models that could do that. And the combination of the GPS data representing so much of pronghorn over such a big area over such a long time, the satellite record matching that, and now having the tools to do it, that really lets us ask these questions of how has the habitat changed and how have pronghorn responded to it. And so we started doing the work. We fit these models combining those data sets. A number of different things went into there, including barrier effects. That's what some of this is quantifying. But what we were able to do is figure out what habitat drivers contributed to habitat quality, account for the effect of fences, where you can see that if a pronghorn's standing here, this habitat's much less useful. The effect of highways, which actually darkens this. I'm not sure the color comes through very well, but there's some color here. There's none here. The highway's a much bigger barrier than we thought. But also the fear effect on habitat quality. So we can break this habitat quality into the components that make it good or bad for pronghorn. And we've developed a workflow to scale this out and project it over the entire Landsat record. And what we're going to show you today is what we've implemented so far for the Marfa Plateau and the Meriton Basin. And this is what we see. This is 5 years of habitat change on the Marfa Plateau. And you can see what month and what year is represented here. 2020 had pretty much no growing season. But when we get to, give it a second, July, August, September, October, and then the winter, we have huge changes in habitat quality throughout the year. But it's also really spatially variable. We're tracking the green wave. That's exactly the green splatter that I was talking about. And I'm not going to make you watch all 5 years. We can summarize this. This is that same graphic right here, but now we have this time series that shows you how good that graph looks through time. And so you can see these seasonal cycles of green up and drying out and cooling off. See that we have really bad drought years, some better years, 2 drought years in a row. Our pronghorn weathered that, but the habitat showed it. And we could show you the entire time series from the very beginning to now, but we can also summarize this in some more convenient ways. We can look at what's going on with our lowest quality habitat through time. So our February habitat quality, that's when conditions tend to be the worst for pronghorn. And what you can see is that our February habitat quality before 2006 was really variable. And it's stabilized afterwards. So our rock bottom conditions are more typical, like they're more predictable now than they used to be. And at first we thought that might be a satellite issue, something, and we've checked and we can't find that. We're not sure why that's happened, but that seems to be a real pattern. The other thing to point out, and this is just a use caveat here, is there's quite a bit of missing data prior to 1995, particularly in the winter. There were more clouds in the winter back then, and so there's more occlusion of the images, which is interesting. But we can also look at the changes in our peak conditions overall. And this is what it looks like in September of each year for the entire record. And our peak conditions are really stable for the majority of the record. Except for, 1991? It's kind of bad, but the rest is pretty stable, which is interesting. Overall, the trend is flat. But this is summarizing the whole Marfa Plateau. We've got this at every Landsat pixel for that whole plateau. And so this is what the trend looks like for our lean conditions, our February habitat quality, versus our September conditions, our peak habitat quality. And what we can see is that plateau-wide trend masks a lot of local variation in what our peak habitat conditions are doing. And what we see is that the western Marfa Plateau has had the greatest rate of loss, so less productive during our peak years. And that's a really interesting pattern. And so we can summarize any number of things about this change. We're just starting to unpack what that tells us. But we're also expanding this and we're refining it. The implementation, the Marfa Plateau, really just spans these two center tiles right here. All 12 of these Landsat ARD tiles are featured in our model. That's what we're expanding to, including populations in Chihuahua, because there actually are some pronghorn between Juarez and Chihuahua City. And we're able to capture their habitat too. So we're expanding the spatial footprint to include the Trans-Pecos and a little beyond. What we're also doing is figuring out how to tackle brush directly, because we have this issue where we're able to capture how green the vegetation is, how productive it is, quality of it, but not what it is just yet. And it turns out that actually tracking brush canopy cover in near real time like we're trying to do is really difficult. But we have an illustrious master student back there who's taken that head on, and another one taking it on for mule deer in drier country. And we're actually having some pretty good success. And so we're going to implement that into ProngMap to account for that in the near future. And that's what we've been building to. Next year, we're going to unveil an interactive web-based tool that anyone can access to understand pronghorn habitat change. The idea is that you can enter an area of interest, say it's a ranch boundary, a pasture, pronghorn herd unit, whatever it is that you're working with, and get a summary of how that habitat has changed, where it's changed, the degree of change, and maybe what the contributor is. Now, right now, we're focusing on that productivity change, and that does tie in some of the brush information because it's less productive on a pixel scale than, say, grassland is, but we want to separate that, so it will improve. But we're using the entire record from 1985 and building it out so it automatically updates every month until the end of the service life for the Landsat program. That's version 1.0. We're already looking past that, right? The brush issue is something that we really want, because the biggest thing in pronghorn habitat management is brush management. And the ability to plan that and be targeted in areas that are going to have the most benefit to pronghorn habitat is really valuable. So once we have those tools in place, we're going to add them to ProngMap to allow projection of, if I implement 10,000 acres of brush management, that's a lot. Let's maybe say 1,000. Where would that 1,000 acres have the best impact for pronghorn habitat? We'll be able to run those scenarios. If you can do 10,000, do it though. And so that's what we really want. The other thing that will facilitate is post-treatment monitoring, so you can see how effective that treatment actually was at improving their habitat. And the ultimate goal is for this to be a living program. And as our understanding of pronghorn gets better, and as we have a better handle on how to map the things that are important to pronghorn, we want the tool to grow. We want it to make rigorous science-based decision support accessible to landowners and managers. That's the ultimate goal. And we're not stopping with just pronghorn. We're collecting these kind of GPS data sets for a number of species. And so we want to extend that to include mule deer, bighorn, elk, aoudad, you name it. We're interested in that because it allows you to then start doing species-specific comparisons and making sense of management trade-offs between choices. What's going to benefit one species versus another? That's where it's headed, but it starts next year. Take any questions.
So you're saying a lot of us have questions about the impacts of elk that are expanding throughout the area. So you're saying next year you'll be able to start getting some of those figures of how the elk, say, for instance, affect mule deer populations, pronghorn populations.
Well, next year is just pronghorn. We're working towards elk. Sorry, I should have been more clear about that.
Start somewhere.
Yeah, but exactly. That's exactly how it is. We're starting somewhere. But pronghorn is our most extensive data set. That was a natural place to start.
When the highest population, pronghorn-wise, have you been able to see a big change in habitat to now? I mean, is it correlating that the habitats change that much to have a big impact on the pronghorn?
We think so. At least I think so. I'm not going to speak for Sean just yet. But, a lot of the big populations of pronghorn during that peak were in the western Marfa Plateau. I mean, some of where those center pivots are, that's called Antelope Valley Farms for a reason. And that's where we do see some of the biggest loss in productivity. And so those places that we do see that decline probably are some of the places that historically were more important for those populations at their peak. So I would think yes.